Saxon's Calculus Lesson 86 is about particle motion for the third time. Let's jump to example 1. A particle moves along the x-axis such that the acceleration function is 3t. If the velocity at t equals 0 is -10, velocity, and the position when t equals 0 is 6, position, find the equation which describes the position of the object as a function of time, and what is the position when the time equals 2 is ultimately the question. So we need to start with our equation that they give us and integrate and work it backwards. So the first part after we integrate is dealing with the velocity. So the integration of 3t dt would be squared. So 3/2 t cubed. Wait, no. Good grief, I've gone too far. T1 plus 1 is 2. Yes, I did it here and then wrote it wrong here. So 3/2 t squared plus RC, and then we are going to fill in the given velocity numbers. So -10 is what it will equal, and our 0 gets plugged in for our t, so that all goes off, so c is basically -10. So now the new equation that we're dealing with is 3/2 t squared minus 10 to solve for the constant. And then when we have integrated this one, we will be at our position equation. So now that is going to the t cubed, and then 1/3 with that. Well, the 3's are going to cancel off. So we basically have 1/2 t cubed minus 10t plus RC, and then we will fill in these numbers. So 0 and 0 drop off, and basically leaves me the fact that c equals 6. So now we put it all together, and we have 1/2 t cubed minus 10t plus 6 is our position formula. And we then need to be plugging in for f of 2. So that's going to be 1/2 2 cubed minus 10 times 2 plus 6. And that will be 8, 4. 4 minus 20, -16 plus 6 is -10. So -10 is the position, and it wanted the equation before, which should be technically then, I guess, the one I should box would say that that's f of, t, sorry, it's t's in there, so f of t would be that equation then. Example 2, a particle moves along the x-axis such that the acceleration function is, a sub t is -3t. If its position when t equals 3 is 20, and its velocity at, which one was that? Position. And its velocity at 1 is 5. What is its position when t equals 4? So again, I need to work it backwards, and that is the same thing I had here, except that it's negative. So that's going to make this -1/2 t cubed plus, no, it won't be the same. This front part will probably be the same, but no, because these numbers were different. Never mind, we do have to work it. I was hoping I could shortcut that. Okay, so this is going to become -3/2 t squared plus c, and then we are plugging in the velocity part for the 1 and the 5, so equals 5, and the 1's here then make -3/2 plus c equals 5, so then c will equal add 3/2, common denominator makes that 10, so 13/2, Now we integrate again our negative 3/2 t squared plus 13 over 2. And that goes to, and the 3's cancel off again, so negative 1/2 t cubed plus 13 over 2t plus c, and then we are going to fill in the position, so that's going to equal 20 when I'm filling in 3's here and here. 3 times 3 is 9, times 3 is 27, so negative 27 over 2 plus 39/2 plus the c equals 20. Okay, those are already in a common denominator. So 27, 37, 30, 12/2, so 6, positive 6. Moving the 6 over, then c would be 14. Yes. So now our equation is negative 1/2, go back to t cubed, plus 13/2 t plus 14, and that's the equation, and it wants us to find it at time equals 4, so we plug in our 4, minus 1/2 4 cubed plus 13/2 times 4 plus 14. Calculator that. The 4 cubed is getting kind of big. It's possible I could do it in my head, but I'm just going to look at their answer, and it should be coming out 8. Let me just make sure I didn't have a number that was dorked. Negative the 4 cubed and the 2 and the 13/2 and the 4. Yes, that should give you to the 8. Example 3. A particle moves along the x-axis so that its velocity at time is given by 1 over t. If the particle's position is 5 when t, oops, sorry, I meant to write 2, is 5, and that was for the position. Find the time when the particle is 10 units to the right of origin. So we first need to integrate our 1 over t, and that we should recognize is natural log of t plus c. And then technically it's an absolute value in there because I don't know what sign I'm dealing with. And then we're going to plug in that 2 and 5. So the natural log of 2 plus, and the absolute value doesn't matter, plus the c equals the 5. Calculator that and subtract it from the 5, and you should get that c is 4.31. Now we have natural log of the absolute value of t plus 4.31. And then it wants to know when it equals, when the particle is 10 units to the right of origin. So that's going to set this equal to 10, and we're basically solving for the time. So you're going to subtract the 4.31, that leaves you with natural log. Then you're going to have to, on the calculator, undo natural log by doing inverse of that. And it might have something to do with your E button on the calculator. But once you've inverse natural logged it, your time should be 5.69. Is that in? I was looking to see what that was in. I just realized that it doesn't matter. I'm not quite there yet. That is the answer I'm getting when I'm doing 10 minus this, not the time equals. This is still natural log of t equals that. Sorry. Now do the inverse natural log of the 5.69, and that should be giving you, here we go, 295.9. Again, I still need the thing, so I'm thinking it should be we're solving for time, so it's the seconds. Velocity time is, oh, it didn't say. Okay, so we're just gonna say it's 295.9.